Okay, so what I have here is this food dehydrator that I bought 3 or 4 months ago at the pawn shop for $10 to use to dry out my filament. A lot of people use food dehydrators to dry their filament, keep the moisture out. Well, now that I've actually tried to use it, I discovered that it doesn't work. And in investigating why it doesn't work, this little goodie right here, hopefully it'll focus on that. I don't know. It's called a microthermal resistor or thermistor, and it's like a fuse activated by heat. If it gets too hot, it breaks the circuit and doesn't work. On this food dehydrator, we got a power lead coming in here through the switch and then into this side of the panel that holds the heat element, and then it would go across right there. I'll get my shadow out of the way. So that's where that thing would live, is between those two connections. It was broken. So the situation is, when I turn it on, nothing happens. So if I jump across this connection where that thermistor lives, I can turn it on and you should see the panel run and the heating element will actually start heating. Okay? So I know that's what the problem was. I went to the appliance store, and in the HVAC system stuff, they have thermostats. This one happens to open at 150 degrees and close at 130 degrees, which is well, I'd have to do the math, figure out what the Celsius is. I'll put that on the screen later. But what I want to do is, I want to put that in the circuit, and I don't want to just, let me unplug this thing. I don't want to just put it in place of where the thermistor was, because when that cuts power, when that circuit breaks, it cuts power to the transformer, which also cuts power to the blower motor, the little fan. I want the fan to run all the time. And if I jump just it, okay, jumper wire, turn the switch on. Stick this down in here, try and get it to make contact. And then make contact over here, and the fan runs. So I know that the fan will run straight off the transformer, if the transformer has power. So what I'm going to do is, I'm going to run the power from the transformer directly to the power supply, which is the switch. Turn that off and unplug it so I don't get zinged. And then I'm going to run the power from the transformer back to the heating element through this 150 degree thermostat. Okay, now I got a connector on there. I'm going to connect that up to the heat switch. And now, so I have power to the transformer, I have power to the heat switch, through the heat switch to the heating coil, back to the transformer, which is what I had before. So now, with any luck, I turn the fan on and it'll run. And I got heat. With a heat switch, so that if it gets too hot, it'll shut the heating element off, but still leave the fan running. So I'm gonna turn this off for a second, and I'm gonna, wow, that's hot. That's really hot. I'm gonna pretend that this is cut off and turn it back on. The fan still runs, so it'll blow air across the heating unit and cool it down, and then that switch will reset and everything will be golden. Happy days. Now I got to put it back together. Hear it running. There it is. I'll put back together. Got a couple of spools of filament in it now, and time to turn the lights off. So it's been sitting here running for 24 hours with the 2 spools of filament in, and I'm going to shoot the table. I don't know if you can see the laser dot. Table's showing about 75 degrees, and now I'm going to shoot the side of the dehydrator, showing about 84, 85 degrees, depending on where I hit. $86 maybe, 119, 118, 125, right there in the corner where the air comes out, 130, 129, down inside there, about 129 or 128. PLA filament, ideal cooling or dehydrating temperature is about 113 or 115 degrees. So I'd say this was a success, and I'm in the ballpark. Thanks for watching. Thanks for subscribing. Consider joining the 400 AGL Club. Help support projects like this. We'll see you on the next one.